Hello viewers, welcome to UVolve, the channel for database and data professionals. This is the second part of the topic on a simple project in the field of data analytics using Kaggle, Python, Oracle Database, and Microsoft Power BI. And in this part, we are going to perform the ETL activities on a dataset downloaded from Kaggle, which will be used for our data analysis. So viewers, in the last part, or the part 1 of this series, we created our software environment for this project where we created our free Kaggle account, installed Python and related tools and packages, installed Oracle Database, the Microsoft Power BI, and also tested to make sure all these components work together without any issues. If you have not watched the part 1, I strongly suggest you watch it first and set up your environment so you can perform the ETL activities that we are going to cover in this part 2. Now, to download the Kaggle dataset using Python code, we need something called Kaggle API. So to download the Kaggle API first, we will log into the Kaggle account. And then go to settings, click on the profile button at the top right corner here, and then from the menu select settings. Then scroll down under this API section, press this button, create new token, and it is going to download one JSON file. It's just 68 bytes and it's already done, and all we need to do is to copy this file as instructed here. Ensure kaggle.json is in the location, that is the user's home directory, and under that .kaggle. So we'll go to the download location. From there we'll copy this kaggle.json file, and then we'll go to user's home directory. To do that, first go to the C drive, users, and as I logged into this Windows computer using an admin account called win10admin, so I'll go to its home directory, and under that I'm going to create a folder with the name .kaggle as instructed, .kaggle, and I will simply paste the file that I copied from the download location. That is the kaggle.json file. Close this. Now we are going to run the VS Code application to write our Python code. So click on the start menu, then type in VS Code. So I'm going to create a shortcut for this VS Code so that I don't have to type in every time. So I'll select the pin to taskbar option here, and that has created this. Now run VS Code, and these are the files that we created the last time during part 1. And now we are going to create our new Python project file for the data analytics project. So click on the new file, and we'll put a name as data analytics.py. Now before I write any Python code for the project, let's first make sure that the packages that we installed in the last part are present. So I'll use the command pip or pip list. If you remember, we installed two packages called Kaggle and pandas in the first part. So let's scroll up in this list and make sure that they are present. Yes, the Kaggle is there with version 1.7.4.2, and the pandas package is also there. If for some reason in your environment it is missing, or you have not yet installed those two packages, you can simply install them using pip install Kaggle or the name of the package here like pandas, etc. So in our case, now both the packages are present. So I'm going to download the Kaggle dataset from kaggle.com, and for that first we have to import the Kaggle module or package in our code. So import Kaggle. Then in the next line we will write Kaggle API authenticate, and this is a method which is going to authenticate our session with kaggle.com using API that we downloaded and put it in the .kaggle directory, and there is a JSON file if you remember. Next, in the line number 3, we will use Kaggle .api .dataset, and from this list we will use this method dataset download files. Press enter, and then within bracket we have to specify the name of the dataset along with the path to where it will be downloaded and one option to unzip it. But first we need to find out the dataset name again under my Kaggle channel or Kaggle account. To do that, we'll go back to my Kaggle account and then go to dataset. I'll click on your work and then click on the employee salary data. And from this address bar, I just need to copy the name of my channel or the Kaggle account, that is uvolve data / employee salary data. And you have to copy this accordingly. Exactly this particular string you have to copy, uvolve data / employee salary data. And then we will go back to the Python coding, and within single quotes we have to provide this and then comma where we want to download. We want to download it to our current directory. So I'll just copy this from the terminal window and then I'll paste it as path equals to, within single quotes I will paste the full path. Now one modification you have to do here is, you see these backslashes there, and the Windows backslash is not recognized by Python. So we have to replace these backslashes with front slash. So users / win10admin / project under documents and under that Python. So this is important. Make sure that you modify all the backslashes to front slash. Then comma unzip equals to true. Save the Python file, and as soon as we are going to run this, we should be able to see a new file is listed here with the name of the downloaded CSV file, and click on this run button. And yes, dataset URL is listed below, and a new file is listed here, employee salary data. So this new file is now downloaded to our Python project directory. If you want, you can check that location, and there should be a CSV file under projects Python and EMP salary data, the comma separated data file that it just downloaded. Next, we are going to comment out these lines because these are just one-time activity. We are not going to download this file repeatedly as we run this program because this is already downloaded and it is with us locally. So I'll comment out these lines, and then we are going to add the subsequent lines. First of all, we are going to import our pandas module or package. So I'll use it as import pandas as PD. And in the next line, we'll simply put df, that is a data frame, equals to PD dot read CSV. We'll select this method, and then within bracket we will supply the full path of the CSV file. So this is in this particular directory. I'll just copy it, put it in the double quotes, and then the name of the CSV file. And you see the name of the file. Just to avoid any mistakes in the name, I'm copying the file name and putting it there under Python directory, that is employee salary data .csv is the name of the file. Then I'll simply print the data frame using print function, and within that df dot head, because we don't need all the lines in the CSV file. We just need the top 5 or 10 lines just to make sure the data is coming. So this is all. And then we'll save the file and execute it. So this should display the top 5 lines of the dataset. In the terminal window, you can see that it is listing the top 5 lines with index as 0, 1, 2, 3, 4, employee ID, first name, last name, department, join date, monthly salary, and birth date. These are the information related to each of the employee in that data file. If you want to see how many records are there in total, I'll just copy and paste it. If you omit this head option or method from the data frame, then if you run it, it will show us the full frame, but some lines will be truncated and it will give us how many lines are there. So if you see, some lines are truncated and it is saying that there are 525 rows and 7 columns. You can play around with this data frame with different methods and options available. For example, if you want to know how many unique employee IDs are there or how many unique departments are there, you can use other methods, like say I'm again going to use the print first. Then I'll access the data frame, which is df, and we'll start a square bracket, and within that and within single quotes we need to supply the name of the field, that is the employee ID or the department for which we want to see the unique values. Say for example, I want to see the department. How many unique departments are there? And then outside of the square bracket, I'll use the dot to invoke the relevant method, which is unique method, and then we will simply run it to see how many unique values are there or in the department. And it has given a list of unique departments, which are customer support and service, finance and accounting, human resource, information technology, legal and compliance, manufacturing, etc. And there is also one value called nan, which we will talk about later on. Actually, it represents a null value in the department. So until this point, whatever we have done so far with the pandas data frame loaded with our Kaggle dataset are fun stuff. With this, we just made sure that we have extracted the data to be analyzed. Pandas libraries have a bunch of sophisticated methods and functions that can do a lot more. We just extracted the data as a part of our ETL process, and the real fun will begin in the next few steps, where we will clean up or transform the data. In fact, a dataset can have many data issues, such as non-alphabetic characters in the name fields, invalid date format, non-numeric values in the numeric fields, null values in the fields, etc., that make the dataset unreliable. Because analysis performed on dirty data or dataset with data issues will give us incorrect or inconsistent results. So next we will find out the data issues in our dataset or in the data frame and fix them where possible. First, we will see if the first name field has any non-alphabetic characters. To do that, we are going to add a dummy field to the pandas data frame, which will store just a true or false value depending on the corresponding first name field, whether it is having a alphabetic or non-alphabetic values. So I'm going to create this dummy field in the data frame as df. Within square bracket, I'll put an alias for the first name, such as FNA, suppose. Anyway, we are going to delete it later on. So within single quotes, then that equals to our actual data frame, square bracket, single quote, first name dot. We are going to use the str collection here. And this collection will give us a lot of different methods to work on the strings. So dot str dot is alpha is the method that we are going to use. So what it is doing, it will check if the first name field is alphabetic. And if it is alphabetic, then this particular field called FNA will have a true value. And if the value in the first name field is non-alphabetic, then it will store the value as false in this FNA field. And similarly, I'll just copy this line, and I'll also create the last name dummy field as say LNA, and I will change the name as last name, and it will also check whether it is alphabetic or not. And then I want to check one more thing, whether the salary column or the field has any non-numeric value. So for that also, I will copy this line and creating a dummy field, say monthly salary number MSN. So the name of the actual field is monthly salary dot str, and here instead of is alpha we are going to use is numeric. And with this we are checking the first three fields for any invalid values, and then we are going to print the data frame using print function df. Now let's run it and see what it returns. Yes, it has returned the data frame with the additional three fields added to the end, that is FNA, LNA, and MSN. And we see for the first record, the FNA field is false, means there is a non-alphabetic character or non-alphabetic value in the first name field. So let's go there and see, and we see yes, there is a hash value in between, which is actually invalid. We cannot have a hash character in the first name field. So this way there may be many more, but it is listing the records serially, so it may not be listing everything that we wanted to see where the record has an invalid value. So we have to write another statement to filter out the records which has some invalid values in the first name, last name, or monthly salary field. So how we are going to do that? First, let's print a line saying what we are going to do. Say rows with alpha numeric data issues. And how we are going to do that? We are going to use another data frame temporarily as df2, and we will assign the values from the original data frame, that is df, based on a query. So df dot query, and within bracket we will specify a string where it says fna space equals false or lna. Please note that we are using two equal signs for the Boolean comparison here. So lna equals false or MSN, that is the monthly salary, equals false. If any one of these values are false, it means either the first name or the last name or the salary field has a invalid value, and then those records are returned by this query will be assigned to this new data frame named df2, and we are going to print that data frame to see only the rows with data issues. Again, I'm going to use the print function, and within that I'm going to specify the new data frame name df2. Let's first clear the screen of the terminal window, and then we'll run it. And we see the heading as rows with alphanumeric data issues, and there it is listing around 7 records where there is some issue. Like for the first one, there is a first name field is having some alphanumeric character. For the second one, there is a non-numeric character in the monthly salary. For example, you see there is a ampersand field in the monthly salary column. Similarly, there are some other issues. For example, again in this first name field there is a hash character for the 4th row, and this one in the 3rd row we can see that this last name has a plus sign, which is also invalid, and the similar things. Now this is a small case, there may be even more actually, and based on what data issues you can see, you have to decide on whether you should discard these records or there is a way to fix them. In our case, we can actually fix these records by simply removing the special characters which are appearing in the name fields. And also, you'll see that the monthly salary field has some values with blanks in between, which also can be fixed by simply removing the blank character. And how we are going to do that? We are going to use the str collection again to help us manipulating those invalid strings. So what we are going to do, we are going to first replace the first name where there is a data issue with a valid string by replacing the invalid character. So what we are going to do, so df, that is the original data frame, and within that we have our first name field, and then equals to df, the first name field again. You can select it from the list, then dot, we are going to use the str collection, dot, we are going to use the replace function here. And what we are going to replace, we have to specify the character to be replaced first, that is the hash character that we have seen in the first name field with a blank character. Similarly, we have also seen other issues in the first name, like there is a dollar character. So let's check again. So this one has the hash character, the second one has a dollar character, and those are the two records with first name having invalid values. So we'll replace the dollar character also with a blank character. Then let's fix the last name field. So I'll simply copy and paste the line, and instead of first name I will put last name here. Last name. And what are the issues in the last name? We see there are only two records with data issues in the last name. So the first one has a plus sign in the last name field, and the second one has a dollar sign, actually two dollar signs in the last name field. So what we are going to do, we will first replace the plus sign or plus character with a blank character, and then I'm going to copy this line for the last name, and also I am going to replace the dollar sign with a blank. It doesn't matter how many dollar signs are there in the last name field, because all of them will be replaced with a blank character. Then for the monthly salary field, again I am going to copy paste the line, and I'll replace the last name with monthly salary. And let's see what are the data issues in the monthly salary field. The first one we have seen is there is a ampersand character, and then there is a space for the other two. So what we are going to do, we are going to replace the ampersand character with a blank character again. Let's copy this line, and then we are going to replace the space character with a blank character again. So this should fix all the data issues in the first name, last name, and the monthly salary field, which are visible to us. And then once it is done, we don't need these dummy fields that I added before, like FNA, LNA, and MSN. So I'm going to drop them from the data frame. And to drop the dummy fields or columns, all we need to do is to df dot drop, within bracket we will specify the name of the field, that is FNA, but we have to specify a couple of more things there, that is axis equals to 1 and in place equals to true. Now let me explain what this particular statement actually does. It is going to drop the whole column with the name FNA, and that is specified using axis equal to 1. If you do axis equal to 0, then it will drop the row instead. And in place equal to true means it is going to do this change in this same data frame. It is not going to create another data frame for this, because we want to make the modification in the original data frame itself. And similarly, I will make 2 more copies of this to delete the other 2 fields, that is LNA and MSN, that is for the last name field and the monthly salary field. So all these 3 dummy fields will be deleted after the data issues are fixed. And then we are going to print the data frame to make sure that everything is correct. So I'm going to copy this line again here, and I will simply put rows with alphanumeric data issues fixed. And also let's put an underline there to make it distinct, so that when the output will be produced, it will be easier for us to locate. And also I'll put the same line in the first statement where we were displaying the rows with alphanumeric data issues. Now let's run it. Oops, I forgot to mention to print the data frame. So I'm going to use the print function again, and within bracket I will use the df for the data frame. And now let's clear the screen again and run it. And this time let's see the section rows with alphanumeric data issues fixed. We don't see anything with data issues, and this is just for information purpose. You are not going to check all the 500 plus records here whether they are fixed, but it's just for our satisfaction that we are able to see no data issues in this data frame. Now we have fixed first name, last name and salary field, but we have more to do because we have some date fields there. We need to find out whether there is an invalid date or there is an invalid department, etc. Let's first check the join date field. So let's put a comment here, say checking join dates. And how we are going to do that? To check the dates, actually we need a new module or library to be added, and that is called datetime. But we don't need the whole datetime package to be included. We just need a couple of functions or methods. So we are going to use the statement from datetime import datetime, and then we are going to use those methods and functions below. So how we are going to do that? Now we are going to check the same way we did before, first adding a dummy field to the data frame which will store the invalid values. So df, that is the original data frame, within single quotes join date 2 is the dummy field where we are going to assign the df join date, that is the original field. And in the next statement we are going to convert this date to a valid date, and if that operation fails, then we'll come to know that there is an invalid date. So this is the logic we are going to use. So what we are going to do, df join date, this is the original date field, equals to the data frame, that is pd dot to datetime, which will try to convert the date field in the join date column as df join date, comma, we have to specify what format it is currently. So use the format parameter here to supply to that function format. And in the join date format, we see the first part is the day dash the 3-letter month dash the 4-digit year. To specify that format, we have to use %d dash %b, that stands for the 3-letter month, dash capital Y, that stands for a 4-digit year. And then we have to specify one more parameter here. So comma errors equals within single quote coerce, C-O-E-R-C-E. So this last part in the parameter list, that is errors equal to coerce, it will instruct this particular toDateTime function that if it is not able to format that particular date because it's an invalid date, it will simply replace that value with a string called NAT, that stands for not a time. There are some other values also like NaN, which stands for not a number. And that is the reason why I am saving the original value in the join date field to a dummy field called join date 2, so that afterwards we can compare what was the invalid value in the join date, because that value will be replaced by something called net. And once the date value is replaced, we need to also print the data frame with what it has detected or fixed. So I'm just copying and pasting the lines to print something like data with invalid join date, and below that line we will display the rows with invalid join date. How we are going to do that? We are again going to create a temporary data frame, that is df2, and we will assign the values from our original data frame, that is df, where there is an invalid value in the date field. So df, and again within square brackets we are going to put df and then join date dot is NA. So what this statement is doing, it is actually checking all the rows in the data frame called df for the join date field where there is a NAT value, that is not a time. And whenever it is finding one particular record, it is creating a new data frame with those records with the name df2. And then we are going to print this new data frame with the print function, and within that df2. And then we also need to delete those rows from the original data frame where the join date field has a net value, and we are going to do that using the command called df equals to df dot drop na, this last one. In fact, the drop na method will delete any rows from the data frame with a net, nan, or null values in any of the fields. If you remember, we saw a nan value in the department field when we checked how many unique departments are there in the dataset. So those rows with a null value in the department field will also be deleted. And then we will drop the dummy field, that is df dot drop within bracket and single quotes. We will specify the dummy column that we created, that is join date 2 comma axis equals to 1, that is the whole column, and then in place equals to true. Everything looks correct, and then we are going to first clear the screen in the terminal window, and then we are going to run it. Let's see what it returns. And there you go. Let's increase the size of this window so that we can see what it has returned. We see that data with invalid join date, they are all replaced with net, 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 if you see here. And the rightmost column with the name join date 2 is showing us the original values which were replaced with the net values, where we can see dates like 31st November, 29th February, 31st June, etc., which are obviously invalid dates. There are at least 10-15 rows where there was a invalid join date, and that's why those were replaced with this value net, and that was dropped also. Now let's print out our clean data frame where we have dropped the rows with invalid join date. We will simply use the print function, and within bracket we will print the df, that is the original data frame. And just for our information purpose or easier readability, I will again copy these two lines, and I'll print there rows with join date fixed. Let's run it again, and it looks like there's no invalid values in the join date field anymore. And similarly, we'll also fix the birth date field. First, we need to find out if there is any invalid birth date. So we'll just copy this block and paste it below, and this time we are going to check the birth dates. So let's replace the join word with the birth word, because remaining parts will be the same. Data with invalid birth date, and we are exactly going to follow the same steps that we did for the join date field. Rows with birth date fixed. So let's run it again. Before that, let's clear the screen and then we'll execute it. Let's scroll up to see if it has returned any invalid birth dates, and as we can see under this section, empty data frame, it means there was no birth date with an invalid value. So we have taken care of the data issues, and if you like Python coding, you will have always a solution to fix those data issues, and the records with data issues which cannot be fixed, you have to discard them. In a full data set, 5 to 10% records can be discarded because of data issues, but if you discard more than that, that will actually question the reliability of the data set itself, and in that case, your analysis may be incorrect. So you have to make sure that not a lot of data is discarded. Now, we have to do a little more on the data frame because we see the column names are a little confusing. The standard way of naming the columns are actually putting an underscore between the different words. For example, the employee ID should be actually employee underscore ID, first name should be first underscore name, and so on. And we are going to use the same replace function from the string collection that we did before. First of all, let's copy these two lines because we are going to print the clean data just to display what we are going to do in this step. So we are going to fix the column headers. And how we are going to do that? df dot columns equals to df dot columns dot str, that is the string collection that we used, dot replace, and we are going to replace the space character with an underscore, and then we are going to print the data frame again. Let's execute it. Now the column headers are fixed. We see employee underscore ID, first underscore name, last underscore name, department, join underscore date, etc. And then it has returned 505 rows and 7 columns. If you remember, originally our data frame had 525 rows, so it has discarded 20 records for data issues. So 20 records are roughly 4% of the total number of records, which was 525. So this is acceptable. Now our data is clean and we are going to load this data to our Oracle database. But first we have to create a user in the Oracle database which will have the table where this data will be loaded. So let's start our SQL developer application. And if this message is disturbing you, you can change it permanently. So go to change app recommendation settings, and then at the top we have a couple of options to select. Currently it is anywhere, but warn me before installing an app that is not from Microsoft Store. So you can just put like anywhere or anywhere, but let me know if there is a compatible application in the Microsoft Store. So let's select this one, then close it, and then we'll run it again. And this time the message should not be there. And yes, SQL developer is coming up. First, we have to connect to our database. And if you remember, in the last part, we created this connection using system user to connect to the pluggable database, that is xepdb1. So we are simply going to connect to the database with the same connection or the saved connection that we created. So right click and select the connect option, and it has been connected to our pluggable database. Now, as we connected to this database as the system user, which is the database administrator, now we are free to create a new user account. Usually, only database administrators can create a new user in the database. So we are going to create a new user for our small data analytics application. So let's give it a name as app user. So the command to create the user is create user app underscore user. You can put any name there. You can put even your name also. Then identified by, where you have to specify a password for the user. So let's put a simple password for now. Say app user 12345. Let's select and execute it. And we see user app user created. Now a user on its own cannot do anything in the database unless it has certain privileges to work with the database. So what privileges are required in this database by this application user is determined by the application functionality. For our application, where we are simply going to create a table, load the data, and that data will be extracted to our Microsoft Power BI for our analysis. So for that, all we need to do is so that this particular user can connect to the database and create a table. And for creating a table, it needs space. And also we have to specify how much space we are going to allocate to this particular user. And we are going to do that using the grant statement. So grant create session that will allow this user to connect to the database, then create table that will allow this user to create tables, and then unlimited table space that will allow this user to use unlimited amount of table space to create its objects like tables, views, etc. Now, what is a table space? A table space is a logical storage structure in an Oracle database. A few table spaces with the names like system, users, etc. are created by default when you create an Oracle database. You, as a DBA, can create new table spaces, allocate a full table space or a part of the table space to one or more users to store its objects. Now, unlimited table space is something when you don't want to actually limit the user with a certain amount of space. You can also specify something like 25 MB or 25 GB, etc. So for us, unlimited table space is okay. And then you have to specify to and the username, that is app user. So grant create session, create table, unlimited table space to app user. Select this line and execute. And the grant succeeded. Now let's try to connect to the database using this newly created user, because we are not going to connect to the database every time as a database administrator. So what I'm going to do, I am going to duplicate these properties of the existing connection, give it a new name as xcpdb1, and it will be say app underscore user. And instead of the username as system, I will put app user and the password, that is app user 12345, and we are going to save the password, and remaining things like the host name, port, service name, etc. will be the same. First, let's test the connection. Test succeeded, and we'll save it. A new entry will be there, that is xcpdb1, that's app user, and then we will connect. And now we see a new session is established with the user app user to our database. Now this particular user doesn't have any objects in the database, like it doesn't have a table, view, or any other objects. And in that case, this user is called as having a blank schema. A schema is nothing but a collection of different database objects. For example, if you want to see what are the objects owned by this particular user, you can write a query like select star from user objects. If you execute it, I expect to get nothing. And yes, it has returned nothing. It means this particular user doesn't own anything at this moment. Also, if you want to see if any specific objects like tables are owned by this particular user, you can use, instead of object, you just put tables. So select star from user tables will return any tables owned by the current user. And again, we received nothing. It means it doesn't have any tables. Now we are going back to our Python code to load the data to a table in this particular user's schema. Let's minimize the SQL Developer window and let's go back to our VS Code window. And here, before we can start working with the Oracle database, we need to install two more packages which are called SQL Alchemy and CX Oracle. To install them, let's go to a PowerShell, and then I'm going to use the pip install CX Oracle first. And the CX Oracle has been successfully installed. Next, we'll install the second package called SQL Alchemy. So pip install SQL Alchemy. This is going to take a minute or so, and it has been done. Now we need to import the SQL Alchemy package first. So let's go to the top and I'll just import SQL Alchemy, as we are going to create an Oracle database object here for SQL Alchemy. So let's give it a name as ODB. That stands for Oracle Database. Now let's scroll down and we are going to add the database specific Python code. Let's put a comment as, say, loading the data to Oracle database, and below we'll first take the username and assign it to a variable with the same name as username. So user name equals to app_user, the Oracle user that we just created, and another string variable as password equals to app user 12345, the password that we assign to this particular user, and then DSN, that is just a variable. We are going to create a data source string here which will contain the server, port, service name, etc. that we use to connect to the database. So we'll put here the server name as localhost, and again, if you are connecting to a server which is not this particular computer where you are running this code, you can use the IP address or the fully qualified domain name of the server. In our case, it's localhost because the Oracle database is also residing in this same server or the computer. So localhost colon the port 1521 / a question mark and then service underscore name equals to xepdb1. So this is actually the parameter which we have to provide it as per the syntax that is going to be used by Python code, and we have to specifically mention the service name with the parameter service name equal to, and in front of that you have to also specify this question mark where we are going to use the username string that we created before, that is this one, and then again a plus symbol to concatenate, and then double quote within that colon to separate the username and password pair, then plus, and then we are going to put the other string that is the password, and then again plus within double quotes the ampersand character, and then finally plus DSN. And this DSN is nothing but this particular data source name string where we are putting the server name, port, and the service name. Then in the next line we are going to just validate the connection string with a print statement or print function. So print within that con string. This will just give us the output to verify if the connection string is correct. In case we encounter any issues in connecting, we'll be able to troubleshoot that easily. Then also let's put a line above that to tell us that it is printing the connection string. So connection string used, and then we are going to create a database engine object using the Oracle database object that we created, and let's give it a name as engine or ENG equals ODB, that is the Oracle database object, dot create underscore engine, and within brackets we have to specify this connection string that has everything, the data source and the username, password, credentials. And then below we are going to use the last command to load the data using the data frame, that is df dot to SQL, and within bracket first we have to specify within single quotes the name of the table to which the data will be loaded. So let's give it a name as employee salary data, comma, con equals to engine, that is the database engine we just created. And engine is nothing but which will drive our all database activities related to Oracle database, comma, if underscore exists, and that will tell Python that if the table to be loaded with the data is already present in the database, what it is going to do. It can append it, or it can remove the table and load the data newly. So if we put if underscore exists equal to within single quote append, then it is going to append the new records to the existing records in the table. And then comma, the fourth parameter index equals to false. That is, it is not going to use the index which is there in the data frame, because we are going to use new indexes if required in the Oracle database. So we don't need to use the index from this data frame. So all these lines looks good. Now we are going to save it first, and then we are going to execute it. If everything is correct, then the data will be loaded to a table called EMP salary data in the app users schema. So let's execute it. Yeah, it finished without any errors, looks like. And below it is also giving the connection string which is used. Now let's go back to our SQL developer window and see if a new table is created under this schema. So if this particular SQL statement that we used before, which returned nothing, will return at least one table with the name EMP salary data, that it means the table was created. Yes, this time we can see there is one record and the name is EMP salary data for the table. So let's copy this name and do a select star from EMP salary data and execute it. It should give us all the records, and beautiful, you can see all the records are loaded here. There should be 505 records. Let's right click and take a count of rows, and 505 rows have been loaded. So we have successfully loaded the data from the data frame to the Oracle database. Now there are a couple of things we need to do here. First of all, I want to show you the structure of this table. To do that, first let's expand this plus sign against the connection that we used for the app user, and it will give us a tree of all the different objects under that app user schema. First one is the tables. So let's expand it again. It should give us one table, and if you click on that, it should be the structure of the table here, where you can see that these columns like employee ID, first name, last name, department, join date, monthly salary, birth date, this is the structure of the table, and mostly it is taking all CLOB data type. CLOB stands for character locator objects. So it is actually a very huge data type which can store like megabyte size values in it. We actually don't need to use this level of storage structure for the table, because we are simply going to store the first name, last name, which will be mostly 50 to 60 characters long. So we don't need a CLOB data type. But the Python code has created this table for us because we did not specifically mention anything about the data type. So it's actually inefficient to use CLOB here. So we are going to drop this table, and instead we are going to create a new table with specific data type which is required for our purpose. So let's click on this SQL tab here, which will give us the SQL command to create this table. We'll copy that and we will modify the data types in that particular SQL command. And it has given the full command to create the table. We don't need everything. We just copy these first few lines up to this particular bracket. And we'll go back to our initial editor window, that is xcpdb1 for app user, and then first we are going to drop this table so that we can recreate it. So I will use the command drop table app user dot emp salary data. So this app user is the owner schema of this particular table object. You don't have to actually specify this owner schema here when you are actually logging into or executing the command with the same owner or user. So I can just remove this part and I'll simply execute it to drop the existing table, and the table EMP salary data is dropped. Now I am going to recreate it with some new data type. Like for the employee ID, I am going to use variable character 2 or varchar2 10 as the width or size. So variable character 2 is a data type in Oracle database which can hold up to 4000 bytes under normal conditions. So that is enough for us. Similarly, I will copy this, and for the first name field, I'll put the same data type, and this time the size will be, say, 50 characters. And for the last name also, I will specify 50 characters. And for the department, I am going to use, say, 100 characters. Join date will be date itself. Monthly salary, it cannot be club because it's a number field. So we'll use number data type, and within bracket we'll put 10, 2. It means it will be a maximum length of 10 digits with 2 reserved for decimal places. And then birth date, date. And with this structure, we are going to recreate the table. Execute it, and the table employee salary data created. Now this time we'll go back to our Python code, and then we'll execute it again. And as we have put the if exist equal to append, when it will find this table is already there, but there are no records at this time because we recreated the table, then it is going to append the records to that table. Let's run it. And it is completed without any errors, means the data has been loaded. Let's do a select statement again from select star from employee salary data, and the data is displayed. Let's check the count of rows, 505 rows. So all our records have been loaded without any errors. Now, in fact, you can do many analytical things using the SQL query itself. For example, we just extracted all the records, but if you want to see what is the total amount of salary paid by the company, you can use a command like select sum of monthly salary from EMP salary data, and if you execute it, it should give us the total salary which was disbursed, and we can see it is a little over 4.5 million. Say you want to see the department wise salary paid by the company, so you can simply put the department in front of the sum of salary, and then you have to use the group by clause at the end, and the group will be based on the departments. So once you execute it, you see the customer support and service paid $327,000, finance and accounting $398, human resource $462, etc. So this is one kind of analysis that you can do, but this is not what we are going to do. This is just for your information purpose, but actually we are going to use the Power BI for our analysis. Now whatever we have done up to this point with the Python code is the ETL process. We extracted the data, transformed or cleaned up the data, and loaded to the Oracle database. And this is something which is done by the data engineers. If you found these activities interesting, you can pursue a career of a data engineer. And with this, I am concluding the part 2. In the next part, that is part 3, we will learn the basics of data analytics and perform the data analysis activities using Microsoft Power BI. So viewers, please provide your feedback in the comment section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.